All right, this is EJ Daigle, and this is CAD for Electrical Controls, AENT 3120. This is Chapter 2, Projects and Drawings using AutoCAD Electrical. The first thing I want to go over is the importance of electrical drawings. So why are electrical drawings important? Well, I think it's pretty obvious as we're designing systems, uh, control cabinets, process controls, discrete manufacturing controls, whatever these control circuits are that we're designing. We need a way to deliver the prints, the wiring diagrams um, to the people that are going to actually build them. So that's probably first and foremost, not just the wiring diagrams, but also the layout of the cabinets, the selection of the different types of sensors and motors and fuse holders and terminals and all these things that are going to be important as they build these. Now, let's say that we've engineered a control cabinet. We've got it installed in a factory. Maybe it's a packaging line. Maybe it's some other automated manufacturing line. And it's up and running now. The importance of that document doesn't go away. For example, we have maintenance folks that are going to do work on this cabinet. They're going to, the line goes down for a day, or it goes down and they get a call and they come out to do some emergency troubleshooting. One of the first documents that they're going to go to are those electrical drawings. And to be honest with you, from the design side, we may not print these out until the machine gets built. But once the machine's built, it's not uncommon for a packet or a set of these prints to actually reside right inside the door of the control cabin. And as the mechanics and the maintenance folks are troubleshooting, they can look real quick and say, hey, this motor starter isn't turning on. Is there a safety circuit? Is there a fuse? Is there something upstream of that might be causing this control circuit not to turn on? And then they can use that set of prints to determine the location of that, maybe where it's at, what size fuse it is, or other things that might be affecting that. So it's not uncommon for these to be stored in multiple locations. Obviously, they'll be stored on an engineer's computer. They may even be stored on a network drive or in the cloud. But it's also very, very common for a set of prints to be physically printed and reside either in the maintenance department or in the control cabinet itself. All right. So next thing I want to do is I really want to give you guys an introduction and kind of I don't know, like a hello world to the AutoCAD Electrical. So the first thing that you'll see in AutoCAD Electrical along the left-hand side, and I'm going to close out this drawing for now and just kind of get back to this splash screen as it would be. When you go into AutoCAD Electrical, and let's say you want to open up one of these demo folders like NFPA demo, you can go ahead and open that up. This NFPA demo is actually what we call a project. And a project is nothing more than a folder that contains drawings. It does get a different file extension. It's a .wdp file, the project is. And then within that project, it's very common to see a set of subfolders. In this case, you'll see a schematic subfolder and a panel subfolder. If I go into that panel subfolder, you'll see .dwg files. And if I was to open this .dwg file, let's say dwg demo 09, what I'm going to see is a panel layout. And so like I was mentioning before, it's not just important to give the technicians, the machine builders, a set of prints from which they can build the machine as far as the wiring goes, but it's very important to show them how to locate these parts. So if I've got a motor starter, I will not only tell them what motor starter to use, but I'll actually give them the physical spacing of the motor starters and the motor starter numbers and some tags or some descriptions to tell them what that thing's for. I'll even tell them where I'm expecting the wired ductway to sit, where the power supplies will be mounted, where the PLC will be mounted, terminal blocks that may be in here, fuses that'll be in here, all of this stuff that's in here. What's interesting about this, though, as you look at this diagram, the panel drawings don't contain any wires. So they really are the physical location of the hardware components. And that varies quite dramatically from the schematic drawing. So if I go into the schematic drawing and I go into demo 05, let's say, This does not show the physical location. It may show that I have a PLC rack or a slot for an I/O module in a PLC, but it's not going to tell me precisely where that slot is or where it's located in the control cabinet. So again, two sets of drawings that differ greatly in what they do. Schematics are going to show your wires and all your components and how they're wired together. And the panel is going to show the physical location of the hardware components as they're mounted. So you need both sets of those prints if you're going to build this machine. Now let's say we're going to look at this real quick and we wanted to maybe move one of these components. Well, first off, before we move it, let's talk a little bit about the mouse. The computer mouse is a very important tool when dealing with any CAD software package. I've seen people try to work with the touchpad on a laptop. And although you can do all of that, and some people get pretty good at it, I will tell you that, especially if you're learning CAD early on learning CAD, it really helps to have that scroll wheel and to have, three separate mouse buttons that you can use. So the first thing I'll tell you is I'm using a $20 little gaming mouse that I bought on Amazon.com. And I've seen people buy $300 drafting mice, and you don't need that. You really, especially when you're starting out, a USB plug-in corded $20 mouse is plenty good. That's all you really need. And once you get a feel for what you like and don't like, then by all means go spend more money. The first thing I'll tell you from this Demo 05 drawing, I was closing this one out here apparently. This Demo 05 drawing is if I want to zoom in on a component, let's say I want to zoom in on this proximity switch, I just can kind of put my mouse near that proximity switch and scroll in with the scroll wheel. And I can see that proximity switch plain as day. If I wanted to pan across now, I can hold the scroll wheel in and I can pull the drawing to the side and go all the way over to that input. So I can find out that this PRS 504 is actually wired up to I:1/01. And I can see exactly what the description of it is and what terminal board it may hook up to and all of these different things. So again, zooming in and out with that scroll wheel and then pressing the scroll wheel, holding and dragging, I can pan around. If I want to zoom back out to the full extent of the drawing, all I got to do is double click on that scroll wheel, like that, like so, and you'll zoom out to the extent of the drawing. You'll get a full image of the drawing, and I might have another ladder on this side that I need to get into, so I could scroll into that side as well. So again, the zoom in, zoom out, the pan, the double click of the mouse wheel, all of these things are very important as we're working with AutoCAD Electrical. Now I'm going to just kind of close that folder down a little bit. And let's say we wanted to create a new project. If I wanted to create a new project right now, I could go into New Project within the Project Manager here. And if I click on that, it's going to ask me for a project name. And this class is called AENT 3120. So I'm going to give it the project AENT 3120, and it's going to put it in the project folder. I would leave the defaults alone for now because they're going to work really well and everything will come in, and that's where AutoCAD is pointing to begin with. I'm going to hit OK, and now you'll see an AENT 3120 project. You'll also notice that that 3120 project is bolded. What that means is that is my current active project. If I click on that project and I say, you know what, I want a new drawing, I can go in and create a drawing within that folder. And maybe I'll call this my MCR circuit. MCR CKT is all I'm going to call it. I can also pick a template that I want to use. So I'm going to browse for templates, and I'm going to pick the AutoCAD Electrical and hit open. And what that template really does when I hit OK is it brings in kind of this title block and this format of a drawing. So it gives me a nice little a drawing pad from which I can build and where I can edit the title block and do what I need to do. All right, so we're in our drawing now. And now what we want to do is we want to start building some stuff. So the first thing I'll do is I'll go up here and I'm going to grab a ladder diagram. So I'm going to insert a ladder. So by clicking on here, insert ladder, it's going to come up with some defaults, but I could change the width. If I wanted to change the width to, let's say, 6, I guess I will. I don't know why I am, but I will. I could also change, that's the width between the rails. I could also change the spacing between the rungs if I wanted to. I could also change the reference of the first rung. Let's say I didn't want it to be rung number 1, but I wanted it to be rung number 101 for some reason. I could select single phase or 3-phase, and I could also draw rungs individually as needed here. So what I want to do is go ahead and hit OK, and then I'm going to left click and I'm going to drag down. Left click again, and you'll see my ladder has come in. Now, because we set up these defaults, we can see that it started at rung number 101. So let's go ahead and place some components. Maybe we're going to draw the MCR circuit as I labeled it right here. So what I want to do is draw maybe an E-stop in here and so on and so forth. What I'll do is I'll go to the icon menu. Within the icon menu, I'll select push buttons. And then I'm going to grab this mushroom head normally closed. I'm going to treat that like my emergency stop. Now, I'm going to actually, I'll let it tag it as PB101. The 101 is because it's on the line 101, the rung 101. But I'm going to give it a description of E-stop, because I know I'm going to use that as my emergency stop. Now, let's talk a little bit about some of the things we can do from here. The first thing I want to talk about, I've got a ladder in here. But I do have some drafting settings that I can use. So down here in the drafting settings, you'll see you can turn the grid off and on. So I can either have the grid in the background or not have the grid in the background. And right next to that is a feature that's important to know about. This is called the snap mode. And you'll see that it's toggled with F9. I'm going to talk about that F9 snap mode here in just a minute. But before I do, I want to show you guys the marking menu. So in the marking menu, what I will do is I will right click on my component and it'll bring up my marking menu. From my marking menu, I can edit the component, I can delete the component. I can use Surfer. Surfer is kind of an interesting tool that allows me to surf from point to point. So as an example, if I had a coil connected to other contacts, I could surf from point to point, or if I had a break in a line, where it broke from one line and went to a different line on a different sheet or a different rung, I could surf across those. I can tag or retag. I can copy a component. I can scoot, align, and move. And these are the three that I kind of want to talk about right now. I'm going to do a move component first. And what I'm going to do with the move component is I'm going to select that move component. And right now, my snap mode is not on. What that means is as you look at this, I'm moving that component around freely. And down here, I can see my snap mode is off. And I can move this component around freely. If I turn the snap mode on by clicking on F9, what you'll notice is it's snapping to grid elements on here. This can be both annoying and it can be very, very helpful at times. If you're trying to line up to a line, that line is attached to a grid component. And imagine that the distance between each grid, there's a little block, almost like a little microgrid. So I can go from this grid line to this grid line. You can see how it bounces between them, right? So you can see this is really handy if I'm trying to get it to line up precisely to a line and for some reason it's not. So I can move a component around. Moving it around with the snap mode, it kind of bounces around. If I turn the snap mode off, it moves around smooth. And now I can just place that component wherever I want. Now, one of the things that you'll notice right there is we've got a problem here. You'll notice that the component right now is not connected. How do you know it's not connected? Because you can see the line is actually penetrating through the component. The line should be wired to a terminal, and then I should see the component and then a line coming out of the other terminal. So this is easily fixed. You know, I could go back and move that component again and try to get it to place in there, and now I can see it's in there. That's also a reason why snap might actually come in handy, right? With F9, if I move, I can tell that I am definitely snapped onto that line versus being a little bit below like I was when I dropped it in there before. And so now I can see it is placed in there. So just a great example of where F9 and snap mode can help make sure you're on that line and you're inserting the component into the line, not on top of the line. All right, now a couple other things. So we talked about the move within the marking menu. We also have something called scoot within the marking menu. Scoot's a little bit different. Scoot doesn't allow me to move up and down. All Scoot does is allow me to move left and right. So it's going to keep me connected to that line, but it's only going to allow me to push left and right. Kind of handy though, because like you saw earlier, when I moved, I ended up being off that line a little bit. So I ended up using the snap mode to get back onto the line. Well, Scoot, if I'm staying on the same line, there is no sense in having to move. I'll just scoot it over as I need be. Now, what if you, and again, we can do other stuff too, right? We can copy a component. I could place a bunch of emergency stops in my circuit here, right? If I want to copy this again, I could do that. Copy component again, and so on and so forth, right? Now, let's say for some reason we wanted to line these three up, and I really wanted to align them by push button 102. What I would do is I would right click on push button 102, bring up the marking menu for push button 102, and I would hit the align button. Now you'll see it's going to draw a vertical line. It says, oh, you must want to align these vertically. So yes, I do. And I want to align this. So I'll select this by left clicking on it. Then I'll select this by left clicking on it. So right now I have these two push buttons set up to align with push button 102. And because I have the two selected and the original push button selected, when I hit the enter key, you'll see that it will align all three push buttons. And now we're really happy with that align tool. All right, I'm going to hit Control Z a few times. Now it's important to remember Control Z, or up here the undo button as you see up top here. What that does is undoes the last thing that you did. So the undo that I did, the thing I just did was I aligned, and if I keep undoing, oops, I'll keep undoing, you'll see it undoes the placement of the PB103, the placement of the PB102. It'll push this push button over. Oops, moving my mouse around there. If I keep undoing, it'll eventually get back to whatever it was I was originally, all the way back to the point where I was placed on top of the line. And it will even undo zoom in and zoom out as well. So it's a little bit strange in that aspect. But I'm happy right now with where I'm at. I've got push button 101 in here, and it feels pretty good. So now if we're going to do the MCR circuit, what I would do is I would continue to work within the schematic tab here, and I would go into my icon menu, and now I would grab a stop push button. So I'll go into here and I'll grab my push button normally closed, and I'll place that on the line, and I'll call this my off underscore PB and hit OK. And then I'll go into the icon menu again. I'll grab another push button. This one will be a push button normally open. I'm going to give him a little bit of a gap this time. I'm going to call this my on underscore PB and hit OK. And finally, I'm going to insert a coil. So I'll go back into the icon menu, and instead of grabbing a push button, I'll go into relays and contacts, and I will grab a relay coil and place that guy right over here. And I'm going to give this guy a description of MCR. I could, if I wanted to, I could retag this component completely MCR 101, but I like listing it as Control Relay 101 and just giving it a description of MCR for now. So we'll do that. And then you'll notice on the right-hand side, with my coil comes in a list of normally open and normally closed contacts. In this particular case, I don't have any contacts listed yet, so it will not show the line numbers where those contacts are at. But as soon as I add a contact, which I think I'll put a contact in parallel here, so I'll go ahead and go to the icon menu, go to relays and contacts, go to normally open contact, and place him in parallel, just like so. And this is where the tag becomes important again. My tag for the control relay coil is CR101. So I want to make sure that this tag also gets CR101 as the tag. You'll see it also gets the description of MCR, and now the normally open contact is listed on line 102. And now you might be like, oh, I see where you're going with this. We want to put a holding contact in for this normally open push button. So we'll grab a wire up here under the wiring tool, and we'll drag a wire from there down to there. And I still have the wiring tool active. You can see when I mouse over it, draws a little green X. I'll draw down from there down to there. And now I have my holding contact in there. Now we've got a little bit of a problem, of course. Now I still have the wiring tool active, so be careful. If you want to deactivate a tool, all you have to do is hit the escape key, and that tool is now deactivated, and you can see I don't get the little green X anymore. I now actually get crosshairs with a little square in the middle. But I need to get rid of these lines. So what I'm going to do is I'm going to go up here to trim wire. I'm going to click on this line, and I'm going to click on this line. Now that wire is trimmed, so when I hit the on push button, the control relay will energize, then the MCR contact will close, keeping the control relay energized until either the emergency stop or the off push button is hit. So that all looks great right now. Let's just put in another contact to show that we can do this. And so I'll go back to the icon menu. And in the icon menu, I'm going to relays and contacts. And I'm going to grab a normally open contact, place him here. And again, call him CR101. I'm going to go back into the icon menu again, but this time, and you'll notice in the icon menu, you're recently used. So if I wanted to place a bunch of normally open contacts, I could just grab them here. I wouldn't have to drill in to the sub palette or sub menu for relays and contacts. Instead, though, I'm going to grab the normally closed contact and place him right here and call him CR101. And as a reminder, if you can get all bent out of shape about the placement of components, but if you ever want to align those components again, all you have to do is right click on the component you want to align to, click on align, then right click all the components that you want to align to that, and then hit on enter, and it'll align to those components. All right, now what I want to do is I want to add in 2 pilot lamps. So I'll grab the icon menu, and in the icon menu I will go to pilot lights, and we'll say for the normally open, we'll turn on a green lamp when the circuit is energized, and I'll just hit OK. It's going to come in as light 103. And for the other lamp, I will go under pilot lights and I will grab a red lamp, and I'll put him over here, and it's coming in as light 104, and I'm happy with both those. Again, I notice a problem right now. It's very important to notice these, and it's good that these things are happening so you can see them. Having snap-on would have allowed me to place this directly on the line where I want, but because I placed it a little below the line, you can kind of see the outside edge of the circle is below the line versus being on the line. Because I've done that, you can see the lines going through, and light 104 is actually not hooked up to that line. Now there's a number of ways you could fix that, right? You could go ahead and click on it and go to move, and I could click on F9, which is my snap mode, which will help guarantee that I get on that line because it's going to snap to that line. It's only going to give me 3 positions close, there, there, and there. So I'm not going to be able to get off by just a tiny little bit. So I'll snap it to the line there. Then the other thing you'll notice that you probably figured out what I was up to here is I would love to align those 2 lights with this control relay. So I'll click on align. It'll bring in that vertical line. I'll select this component. I'll select this component. And I'll hit enter. And now those are all lined up. I'll hit escape. And my tools are all where I want them to be right now. So I hope that gives you at least a good example of some of the drafting settings, the very basic drafting settings, the use of the mouse, all the things that are in the icon menu. By the way, if there's something you're looking for that you don't find, you may want to look under miscellaneous switches or something like that. There could be another spot where you'd find it. Selector switches, there's all kinds of stuff. Transformers, everything you'd expect in here, motor control, proximity, pressure, temperature switches. You can see all of these things. And even some of the timing relays, like an on delay coil and your, things like normally open time to close and normally close time to open contacts that you'll see in there as well. So that should give you a good demo and at least enough to work with this week's homework in AENT 3120. And as usual, if you have any questions, feel free to reach out to me. And for the homework for this week, my recommendation is go ahead and just take a screenshot of this. We won't set up the title block and some of those things yet. And if you want to, you can go ahead and just paste some text over here. So as an example, I could go into home, I could put some text, and I could draw a little text box over here. And for right now, I might just put in my name, EJ Daigle. I might put in the project or the class, AENT 3120. Maybe this is homework 002 or something like that. And you could include that with your homework, and we would be just fine for this week. I'll expand it out just so it fits on one line. And then really maybe something as simple as taking a screenshot of that and including it with your homework would be enough for this week. So that's all I got for you. If you have any questions, by all means, reach out to me and I'd be happy to answer those. Thank you.